Okay. How is this looking? Let me just see whether I have a lag as well. Looking better. Let me see. Okay, this is better, but still not real time, I guess. Good enough. You hear me now, Ryan? I think we're almost real time. Maybe 5 seconds delay or something. I've set the preset to basically ultra low latency. Okay. Hi, Sergey. Welcome, welcome, welcome. Yes, we hear you just great. Awesome. The sound is good, right, Brian? Let me just see whether all is good here. Looks like I've set my input correctly here. Shouldn't streaming always involve some delay? Even TV has a delay. Yeah, of course. But like, I think it can, like, today it was like 50 seconds. That delay is like unacceptable. Maybe a couple of seconds, of course. But I guess I don't want more than that. Okay, I'm capturing everything nicely. Guys, I think we can start. Like, I basically want to figure out what's going on in fairseq2, what's new there. I want to understand what's new in the SeamlessM4T. And so let's kind of go through the code bases. So fairseq code base is here. I'm going to open it up, and then, as I said, SeamlessM4T, GitHub. Let's go there. Let's open up this repo, and let's quickly skim. Let's just start from the README and see what's going on here. Designed to provide high quality translation. We saw the paper today already. So 101 languages for speech input, 96 languages for text input output, 35 languages for speech output. Okay. And this unified model enables multiple tasks without relying on multiple separate models. Okay, just a second. Sorry, guys. Trying to find my chat. Okay. Installation, running inference. We can maybe try and install everything. I think for that I might have to switch to Ubuntu. I'm currently on Windows. I might have some issues setting everything up. fairseq2, Sonar and Blazor, Stopes. Okay. And of course the license, our favorite license. Nice. Well, let's see what's going on here. Here's some code here, scripts, documentation. Let's just quickly skim, understand what's going on here. Documentation. Speech to speech, speech to text metadata. Okay, this is going to be the metadata that's necessary to actually replicate the data set. Naming conventions. Okay. Common crawl. Data. Actual data is here. Okay, they have a bunch of links for different language directions. Download script. Wet lines, scripts to download. So this WET is just some format that you get when you're using Common Crawl or something. The script can be found here. So, okay, so it's a different repository. Wet line, some C++. C++ code or whatnot. Okay. Example usage. Okay, just grab. Hey, this is a great example of how I like to use JGPT, by the way. Okay, display the contents of the compressed file without actually decompressing them. Display the contents of the file's name, blah, blah, blah. That's a compressed file. Egrep is a command used to search for a specified pattern. Okay, and then crawl data is the actual pattern, beginning of the signifies the line. Should we start? Okay, we crawl data. TR is a command used for character translation or replacement. Replace tab with empty space. Okay, and then wet lines like the custom command or script in some specific way. It's not a standard bash command. It's literally works nicely. Like so, yeah. Wet. This is the script that we have to probably install some command line version of it, and then we just basically replace tabs with spaces, and we fetch. Is this fetching the file names, or is it fetching the content in the actual files? I guess the latter. To summarize, takes the compressed searches for lines that start with crawl data, replaces tab character space, and then. Okay, got it. It was more of a fun exercise to flex the ChatGPT than anything else. Okay, based on metadata information it received from std in, the corpora, finds the paragraphs and prints the input, blah, blah, blah. Okay, this was just some details about the data set. On device models, experimental. Okay, aside from the large and small and medium models, they also have a small model, 281 million. Okay, here are the smaller models. Support the task, support the languages. Nice to use these models. Let's see how they do it. Okay. Does this mean they are already? Yeah. Okay. I mean, this is MetaWorks, so I guess they already pushed their checkpoints to the hub or whatnot. I wonder how big is the delay, by the way. Hopefully not that big. Okay, let's see, what is this? Okay, just a metric. Okay. This is just about evaluation protocols. Okay. That was the documentation. Let's see, they have some scripts here and M4T scripts for predictions, inference with seamless M4T models, 5 tasks. If you want to run from the CLI, can be specified like this. Okay. The input audio must be 16 kilohertz. Here's how you could resample the audio, and then just a simple snippet here. Okay. Hey, Emir Khan, I'm not sure how real time this is. Let me know as soon as you hear my hey, just say something. I might switch to Twitch in case this is like super slow. Okay, so we initialize the model. We say which vocoder we want. Where do we want to load it? Model. I have 2 GPUs, so and then use predict. We pass the audio, we say what we want to do, and then target language. Okay. Supported languages, a ton of them. Okay, fair enough. Let's check out the predict script. Okay, I see the smiley, but I'm not sure when you posted it. I don't see the timestamps. Fuck. Yeah, we can try Twitch from tomorrow. So let's see what this does. We pass an input, a task, target language, source language, output path, model name, vocoder name, n-gram filtering, and then if we have CUDA, we're going to use FP16, GPU 0. We initialize this translator object. We call the predict, we get some translated text, and then hi, I have one question. Did you improve your coding while learning, as no one was reviewing your code? I'm not sure what exactly you mean by no one was reviewing my code, because I did work at big tech the whole time, Microsoft and then DeepMind. If one was, how did you improve? Well, I don't know how to explicitly explain. Like, I don't know how to verbalize. It's just like, I guess, trial and error. You build stuff on your own in your free time, and you also learn from your colleagues. Okay, and then they just save the final translated audio, and that's it. Okay, this is a simple predict script, nothing fancy there. Let's see the fine-tuning directory, the audio to units, and then we can maybe, I don't know, we can maybe try and run something, although I really want to focus on NLLB, but we're going to start doing that tomorrow. Just a sec. So what's this audio to units? Okay, this is, I guess, one of those 4 block components, if you guys remember from earlier today from the streams. Maybe Brian, if you're active, you can maybe reply to some of the chat messages. I'm trying to focus to go through this, otherwise we won't get anywhere. Raw audio needs to be converted to units to train these models and vocoders. Units act as a supervision for Unity models and are the input to the vocoders which synthesize speech from these units. Thanks, Brian. Okay. compute features on layer 35, determined empirically, dark magic in deep learning. The pre-trained model, which is a Web to WEC model at the core. Okay, I think I remember some of these details from earlier today. Fair enough. Let's skim the code. Okay, unit extractor. All of these interesting models are basically in this path, so we're gonna check that out very soon. Let's see what's going on here. Okay, fine-tuning for English to Korean. Multimodal corpus. Training has 4 parts: audio and text representation of the sample and its corresponding target. Okay, it can be prepared using the dataset script, which is here. Downloads the Flores dataset from Hugging Face Hub, extracts units from the target audio samples, and prepares a manifest consumable by fine-tuning script. A file where each line represents information about a single dataset sample serialized in JSON format. Okay, list of input arguments for dataset.py, source lang, target lang, split. Okay, the notation adopted. Okay, the code. Example bash script that prepares a training and evaluation dataset for translation direction English to Korean. So again, prepare dataset. Is this some of the script above? No, it's not. Example bash script. Fine-tuning. Initializes data loaders and launches training loop before exploring against the validation datasets. Okay, list of input. My advice for improving the code will be to just contribute over the next days once we start building. But like I will have some expectations when it comes to what's good enough quality to be submitted. So we might have to iterate a couple of times, but let's see how it goes. The best way is to just build and do it yourself. I agree with what Brian said. Here are some arguments. Okay, so this is basically that we need the training data set. Path to manifest with train samples, path to manifest with devolve. Base model, do you want to use medium or large checkpoint? So this is the 2.3 billion. Seed, batch size, patience. Learning rate, warm-up steps, the classical stuff. Okay. 3 modes of fine-tuning, speech to speech. All model weights except the text encoder will be engaged. Text to speech, only text to unit part of the model will be engaged. And then speech to text, only speech to text part will be engaged. Example bash script that launches the fine-tuning of the M4T large on the dataset prepared earlier using a single node with 8 GPUs. We'll just need 8 GPUs, guys. I might ping EMAT for help here. Okay, let me see whether there is anything here. Nothing interesting there. Okay, so data loader, dataset, distutils, fine-tune, trainer. I'm at this point just kind of skimming the code base, trying to get a feeling for the structure, for what they offer. So let's start with the data loader. Let's just see what they do here. Unity data loader. Prepare batch, blah, 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 bunch of util functions. Okay. Not that important for now. Dataset. Unity to Floors language mapping. This is just some different codes for the languages. How many do we have? 86, 35, what's that? 52? Difference plus 1, right? Okay. Tokenizer. He means model URI. They have some numpy file here. Encoding function. Okay, here is the download Floors dataset function. Tokenizer. Data builder. Okay, this just creates a manifest file from the dataset somewhere. And this is, we can probably run this. Yeah, we can run this to download the Floors dataset locally. Okay. Okay, these are just some distributed computing. This is, in fairseq, this is all a part of the same repo. Here they are obviously deliberately splitting all of these into separate repos. They're trying to refactor the old fairseq, basically. That's why they have the version 2 fine-tuning script. Let's see what's else here. Trainer, which one is shorter? Let's start with fine-tuning script. Okay, we've seen these arguments before in the README. Tokenizers for the NLLB and for the unit model. So that's a model that maps from text to units that are then mapped into sound waves. Load the Unity model, data loaders, Unity data loader. What's the difference between these two? Eval and train, okay, and then they call the trainer that has the Unity fine-tuned functionality. Okay, so that's where this is where the logic is in. Okay, some forward Unity fine-tune wrapper. Is this the one that we called here? No, I think this is. By the way, I would usually just open up this in VS Code, and then you can easily, obviously, click F12 and just go to definition. But this is simple enough that I don't really need to even download it. I can just do everything in GitHub directly. Okay. Fine-tune wrapper that does a forward pass and returns the logits. Okay. And then there is a loss function here, the loss collector. This is the class that we were using in the fine-tune script. You can press the dot key in GitHub to get a VS Code UI in any repo. Yeah, I actually forgot about that completely. I never used that, but I saw that feature exists. I usually download and run locally. Wait, when you say dot key, what exactly do you mean? Where can I find it? Wait, it's gonna be probably quicker like this. Open VS Code in GitHub. Aha, you mean like on the keyboard, literally? What? But do you have to have some extension or what? Oh my God, nice, 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 nice. Okay, literally the dot. Okay, on the keyboard. Got it. Got it. Got it. Got it. Got it. That's very cool. That's super cool. Well, that's why these streamings are great. I'm already getting some benefit myself. Hopefully, you guys learned something from me as well. This is gonna be awesome. Yeah, let's see how quick it is to load. Well, it's not that quick. Well, it's loading. Let me just reopen. Let me just reopen the where we were. We were here, I think, and then we were in the fine tuning, and then we were in the trainer. While this thing is opening up, let's continue with our pace. Thanks for the tip. Okay, run. What does this guy do? Yeah, it's very slow. Okay, here it is. Here it is. Nice, 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 nice. Awesome. So I can now just use the common stuff, right? I can, if I go to fine tune, and then if I go to here, and if I click F12, well, if I click F12, I guess the bindings are not, if I go here, well, it's not exactly the same as what you have locally, right? I don't have the run paste. I'm gonna zoom in. Thanks. Sorry, Bilal. Let me just try and zoom in a bit. Better now? Let me know if you can see better. Well, the commands, I don't know. Like, okay, this is definitely better than just using the GitHub interface, but I still don't have all of the functionality. I would still have to open VS Code, obviously, and you probably can't run this, right? You cannot run this here. That would be too much to ask for. Okay. Oh, or maybe you can. Oh, fuck. Looks like you can. Nice. That's cool. I guess they're still improving some of the features here. Anyhow, okay. Let's see what's going on here. They initialize the distributed config, device, tokenizers. They have this data class, I assume, up here somewhere. That's in the trainer. Oops, that's in the trainer code. Okay. So this is the one. Okay, I was actually analyzing this code, not the other one. Wait, the transitioning from GitHub to VS Code confused me. Let me just see what's going on here. What are these guys? Okay, that's the data class. And then some error checking, calculate the loss, so some label smoothing parameter, padding index in the vocabulary for speech and for text, wrap model for training. Okay, we're gonna see what it is. Data loaders, Atom, gradient scaler. Wow, what type of a name is this? Mile learning rate. Is this my, and then what does LE stand for? Loss collector. Okay, so that's the init method, and then reset method, and then wrap. Let's see what the wrapper does. Calls this wrapper function. Okay, we're gonna check that one in a second. And then if it's not initialized, distributed setup, then just return the wrapped module, otherwise called the DDP, distributed data parallel, get the rank of the current device. Okay. Just getting a bit comfortable with the code base here. Okay, here what we do is we go through the batches, we assert exist, we calculate the loss between the, so we pass the batch to the model, we get the output, and then we calculate the loss here. If it's NaN, then okay, why don't we throw an exception here or something, maybe depending on the optimizer. Use, okay. Training step. Okay, nothing super smart here. Just a standard loops for training these models. Okay. Loss collector, what is this? Just some aggregator, I assume. Okay. Loss history across nodes. If it's not distributed, then do this. Otherwise, device, and then for each GPU in our cluster, all gather here. Okay. Calculating the loss. Sequence model output. What is this? Some data class again, I assume. From fairseq2. Okay, that's where the fairseq2 comes into picture. We're gonna check it out as soon as we skim through this code base. And then finally the wrapper. Again, this is probably from the, no, this is a local and enum variable. Forward pass. Encode speech. We get speech encoder output, mask, and then decode. Encoder output, projection. Unit encoder output, and then finally the unit decoder output. Here we get back the logits, and that's what we used on there to do the loss calculation. Okay. Well, I don't have to leave this, right? We're gonna stay here. Let me trainer. What else do we have? We have the seamless communication directory. That's the last one, and then we're gonna check out the. It's also worth a while to just see what's going on in the issues. What are some of the most commented issues? And the first one, of course, cannot be completed. Hopefully, don't mind me slurping the tea. I feel so British. Okay. Where is the code here? Assets, datasets, models. Okay, there's a ton of stuff here. Let's kind of skim through this. Okay, here's some. This is probably some how do they call it? Hydra, I think. That's basically Meta's way of doing hierarchical configs with YAML. Okay, here's basically the config for the large checkpoint 2.3 billion. Just specifying the language, is nothing fancy there, nor here. Okay, pretty much same for all of these models. Why do we have these? Probably different script or something. Checkpoint, okay. Download manager. Just curious about the design of this whole thing. Dataset, multimodal sample. Okay. Hugging Face. Why do they have Hugging Face .py? What does that thing do? Assembles. Prepare sample. The best way to get familiar with the code base is to just step through, run some examples and step through. But this is, I love to just quickly skim stuff before I dig into a code base. We won't be, either way, we'll be starting with NLLB, but I'll be just, this is just out of curiosity to understand where they're heading to. And then this is day one. From tomorrow, we'll start doing cool stuff, cooler stuff. I think this is also cool. Ngram repeat block processor. It's cool if they just had simply like some description on top of the script so you know immediately what the thing does. Ngram repeat block processor. I have no idea what this does. Repeat block processor. Maybe some form of deduplication file or something. I don't know. That's the first hypothesis I have. For each hypothesis, generate a list of previous n-grams and set associated log probabilities to -infinity. Should they even try and figure this out? For each hypothesis, generate a list of previous n-grams. Okay, this is just some helper stuff. We can ignore it for now. Translator. Okay, this is going to be probably the main file for the under the inference directory. Get modalities from task. Okay. Predict. If the modality is speech, then audio is the input. We interpret the input as the audio. If it's a string, if it's a path, then we open it up. We read the audio. Some collation. Create the encoder. And then we tokenize. Otherwise, yeah, okay. Otherwise, it's text, and we do some tokenization before we collate predictions, results. Okay. Very abstract. Unit extraction, k-means model. So this is the centroid one. I didn't really dig too deep into why this is what this is, but it doesn't even matter at this point. Let's just kind of skim through it. Again, the idea here is just to get some understanding of the structure. I'm curious why they are moving towards fairseq2 and whether it makes sense to maybe use just something like GPT-NeoX code base to start the replication. Although the thing is, the code is already there, and MIT, it's an open source license, MIT license. It's just that we don't have the checkpoints and we don't have the data sets, which means we can't really use this for commercial purposes or anything. It would be cool to create an API around some of these powerful models and give it to people to use it. Wait, what is this doing? Loads the model, unit extraction, which converts raw audio into units. Okay. Okay, as the output, there is always this k-means model basically outputs the units. That's the thing. resynthesize. Okay, and then this guy here takes the units as the input and basically creates the final wave file, audio file. Okay. Layer output, what's this? Some config for this model. Okay. Okay, let's go further. Unity, adapter blocks, transformer encoder that wraps a speech encoder and adapts it to be used with the Unity architecture. M adapter layer described. This M adapter, what I'm not sure what it is. Let me just see whether there is some simple diagram. Okay, it's just some type of your usual transformer block with some additional pooling here and then some parallel branch with pooling as well. So what's the end-to-end speech-to-text translation models are often initialized with pre-trained speech encoder and pre-trained text decoder. Significant training gap between pre-training and fine-tuning, largely due to the modality differences. They propose M-adapter, a novel transformer-based module to adapt speech representations to text. While shrinking the speech sequence, it produces features desired for speech-to-text translation. With modeling, our experimental results show that our model outperforms a strong baseline by up to 1 blue score on the Massey English to German data set. Okay, basically just some module there. And this is their implementation, a variant of the M adapter layer here. Combine D, so this is just for mapping the input tokens. Okay, we don't have to dig definitely into the implementation of the transformer block. Okay, these are just basic building blocks, as the file says, adapter block builder. Let's just skim through this. So here are the definitions for the models. This is the medium, I assume. Checkpoint. This is just the configuration. How you will rate ETF Belgrade 1 to 10? That's a hard question. I don't know. Not great. Not great. Not terrible. You'll know the reference probably. You might not. Okay, these are just building the Unity models. Okay, you got the reference. Chernobyl. How is the radiation? Not great, not terrible. They're dying. Okay, generator. The reason I say that is because ultimately, yeah, 3.6 3.6 Rengen. The reason is that ultimately everything I learned, I have to relearn a bunch of stuff on my own, and the only reason I got to where I got is because I was doing a lot of extracurricular work. We were not really incentivized to mingle, to network, so we didn't learn anything about business. We didn't learn anything about thinking like an entrepreneur, nor anything about machine learning. So like literally everything I know and do right now is kind of self-study. Ultimately, all learning is self-studying, even if you're at the faculty. It's just that you have some additional external structure. Remove consecutive repeat engrams. Huh. I think there's a lot of people from that are not Serbs here as well. Well, a lot. There is currently 15. I mean, I think over the next days, probably once I start coding, people will start. More people will join. Maybe just study with me vibes. Okay, these are just some. Generator, loader. Let me just skim through this. Wow, what is this? Speech encoder. This looks like some of those old Lua files or like Cafe or something, like with definition of architectures directly, like as an ASCII. Uh, what is a conformer exactly? I forgot. Like it's some. Let me quickly Google this. Oops. Conformer paper. I guess it's in the context of speech recognition. Okay, that's why I don't see it that often. Convolution augmented transformer for speech recognition. They show some type of latencies here. Okay, it's just a particular implementation of course, from Google. Everything came from Google, guys, and yet, yeah, I won't complete that sentence. I'll leave the auto-completion part to you guys. Hey, new guru. It would be cool if you guys had actual names and I can call your names. Okay, model. Okay, these are just a bunch of definitions of all of these various components that we saw in the paper. Well, we have 15 people watching this. I'm famous. Let's see what's going on here. Unit token encoder. Okay, you definitely have to step through this to understand the details. I'm just creating a abstract model of this whole repo. This is for the vocoders, so that's the part. Why do they call it vocoder though? It basically converts, it maps the units to audio files. I remember I saw a better name and I forgot that name. Maybe just audio decoder. Build small. Okay. Res blocks. Why is this implemented here? Why not in fairseq2? Okay. Okay, so they do have everything in here, both the fine-tuning, prediction, training, model definitions. They leverage fairseq2. They have these YAML configs up there. They have dataset loading scripts. Plugin face, checkpoints, everything is here. So let's briefly skim through I'm gonna leave this and let's briefly skim through the issues, and then let's jump into fairseq2. And after we do that, then let's focus on seeing how we can start replicating the NLLB project. I'll create a repo and then I'll start contributing, and we'll see how that all goes. I still don't have everything charted out, to be honest, but one step at a time. I just know I'm going to be doing this every single day over the next weeks. Streaming the whole day. I'll probably start the streams around 10 a.m. and then stop around midnight. We'll see. Commercial license, yes. Being an ML engineer versus doing your own startup. Well, you can be an ML engineer and build your own startup. That's what I'm doing right now, right? It's all personal preferences, honestly. I don't see myself. I really love the feeling of having high agency and just doing whatever I want, building stuff on my own. Check out my blog, Dushan. I think that's gonna be the best answer on Medium. Like, I have good tips on how to get started, and you're gonna find it useful. Albanian language support, out of all languages. Okay. Okay. I think I already skimmed this one. Let me just see what's going on. What are the issues people are encountering here? Okay, there are some rough edges still around the code base apparently. Or people just don't know how to use it. I don't think this guy understands what a commercial license means. Please make it a commercial license. And they fully support him. No, we don't want a commercial license. I mean, like, so that you can use it commercially. It sounds weird when you say commercial license. In my mind, it reads like you cannot use it in that purpose. It's just, I guess, open source license, MIT license, whatever. Apache 2. Is it possible to generate something? Okay, so here's the reply. So they basically don't still support the timestamp feature that Whisper supports. It's not trivial to get the ASR timestamps for a model, unfortunately, since it shares with translation decoding process not monotonic like other ASR. Okay. This is a boom. This is a um, deal breaker for some use cases. Okay, let's see whether there is anything else interesting that we can maybe check out here. Huh, interesting. Somebody's trying to run this on edge devices on Medium. You can find all of the blogs on Medium. Word transcription. For small models, maybe. I tested it on Jetson Orient Nano. Did any of you guys play with Raspberry Pis, or did you have any such projects? Type it down in the comments here. Even after providing an audio file of 54 seconds. We suggest cutting the audio to smaller than 15-second segments using silence detection to avoid truncating within phrases that's where their model works better. So yeah, I guess a lot of rough edges for now. Cool. fairseq. Let's check out fairseq. Let's maybe do a quick break just after having skimmed through this repo. Let's make a quick break, like 1 minute, and just stretch my legs, and I'll be back in a minute. And I'm back. Let me know if you can hear me. I think I hear an echo in my own earbud. Okay. Welcome back. We missed you so much. Nice. Okay, at least the lag is much better than the previous time. Okay. Let's see what's going on in fairseq. What's the thing there? I think there's only a couple of issues. One of them I opened up just to ask whether they are deprecating it. What's going on here? Somebody's playing with SeamlessM4T, and they're hitting some fairseq related issues. yeah, this is going to be just going through the code stream. It's not even code along. We're going to be doing some coding tomorrow probably. And everything else. I'll just be filming everything I do, honestly. So it's a fun experiment. First stream, yeah, this is the first day of streaming. This is my, well, effectively third stream because this same day, this is my third stream already. But this morning I've never done a stream before. If you have any tips, I'm listening. Let's just skim through the README. Still under heavy development, early beta quality. Please use with caution and do not hesitate to share feedback. By the way, as far as I know, Meta has, for each of these open source repos, I've heard that they have internal versions that are different compared to what's out there. So that means Llama was not really trained using fairseq. He was trained using some custom internal fairseq. I'm not sure whether there are any fundamental differences or the internal tools just rely on their internal tools in the infrastructure. Mainly supports Linux. So that means Windows support is not planned. So that means I'm currently on Windows, so I couldn't run this even if I wanted. I have dual boot luckily on my system, so I can next time just log into Ubuntu, and all of the future streams will be in Ubuntu. So these two guys use fairseq2 already. This is like super early days of the framework. You can install it from source. It's MIT licensed. That's nice. That's nice. Is Sonar a different? Yeah, it's a different repo. What's the license of this model? Fuck. Both code and models are CC non-commercial license. And this is the model that they use to basically mine all of the parallel audio data, speech text data. The one and only license Meta knows. Ah, fuck, man. At least they're sharing. I don't know. Like, we're also very entitled, right? And they give us challenges. Otherwise, we wouldn't be building this ourselves. So I don't know. I don't want to complain about them. They are at least sharing. Okay, so what's the thing with fairseq2? Yep, they are the open source champion, 100%. Let's open up some of these directories, and I'm curious because I'm now fairly familiar with fairseq version 1, so it would be interesting to just make a quick comparison between the two. Okay, Let's see where we can start. Let me just quickly skim through all of these files quickly. Let's jump first into training code, assets, data generation, models, memory. Let's open up the generation thingy. Just move it here, and then sec2n contains the native parts, C++, pure Python. Okay. Okay, so this is basically all of this is in C, and we can ignore it as I said here. Thank you. Okay, they don't have any examples yet. Really rough edges yet. What's this? Installation instructions. Oh my God, my brain. Okay, nothing smart here, just some documentation. Probably automatic generation stuff. Okay, so we're left with these two guys. They have some tests, we don't care about those really, nor about this. So this is actually the main file, some assets. What assets do you guys have? Probably some config files for, yeah, NLLB. That's nice. They're probably porting NLLB. Okay. Cards, card storage, download, managers, store. What's this? Information about an asset. Configuration and stuff. Card storage. Download stuff. Store. Data. Tokenizers. Okay, let's start from here. Just trying to find whether there is some similarity with what I've seen already in fairseq. Okay, just some data class definitions. Sentence piece. Where is your training script? And what's gang.py? Set of processes that work collectively. This is some distributed thingy. Fake gang. Okay. Memory. Optimizer. Okay, we don't really care about this. And N. So this is like super early days. This framework is very, very lightweight at this point. How did they even wait? How did they train? Normalization layers, different implementation, layer norm, standard layer norm, RMS norm, and ends, models. Okay, probably somewhere here. Projection, position encoding, normalization, module list, incremental state. What's this? Embedding. And you have to open transformers. Incremental state holds the state of a module during incremental evaluation. Okay. Embedding. Why don't you just use? What's wrong with torch embedding? Utils. Gradient scalar. We saw this one before being used. Masks, paddings. Transformer layers. Just transformer implementation. So that's it. And then there's a couple of models here, right? And there is this. So what's the difference between this guy? Oh, NLLB. Let's see what's up there. Okay, this is just definition for this model. Transformer. Why do they have two transformer directories in such a small repo? NLLB. What do they have for the NLLB? Let me just see this. Curious. Config. Config. Build. Okay. Okay. And finally, sequence generator and text. These two files. And I'm still curious. I'm not sure where is there training data, training loops and logic and somebody called me an AI pirate. Okay. Self-generate, and that stems from what? Okay, I think I want to do one more thing. Let's just reopen the SeamlessM4T GitHub repo. Let's go to some of those training. Where were those scripts? Predict, let's say fine tune. And then let's open trainer. We can close everything else. So for training here, okay. They actually implemented training directly here, right? That's a weird way to set up a framework called fairseq version 2 because all of this logic should practically be, yeah, they're literally re-implementing everything directly here with some leverage of fairseq2. Okay, makes sense. Well, this was quicker than I thought, guys. I thought this is gonna take more than this. When did we start the stream? Let me see. Anyone? When did the stream start? How can I figure that out? 75 minutes ago. Okay, time flies by super quickly. Over an hour ago. Okay, let me think. So basically, we want to replicate and make sure that we have open source versions of the models for NLLB, and I want to focus. We can start with 600 million model, and basically, what's the let me just close up all of these. So NLLB, GitHub. I already am familiar with the code somewhat because I played both with Stopes and with NLLB, which is basically just a branch in fairseq. And so that's one bad thing because this code is super obsolete. They released NLLB last year, and since then they probably have a lot of new patches in their library. But this code kind of runs. I tried it, and I managed to run the inference. I managed to run the training, the fine-tuning, dataset downloading, preparing data, like filtering data. So I have everything, like assuming that we have data, which we don't. So let me just understand one thing. So the license, the code is MIT licensed, but the checkpoints are not. So let me just CC, BI, and so you can see here, all models are licensed under this non-permissive license, which means if we wanted to use this commercially, we can do that. Both these models as well as the language identification model. And the part that I'm interested in is understanding the license behind their data. So they have three types of data sets. They have the primary data set, which is basically the public parallel corpuses that they found. The second type is the mined data, which is basically through the bytex mining process using laser 3. And then the third type is basically the back translated data, which I assume because they use their own models, which are already non-permissive in license, the output of that model is also going to have the same property probably. So I assume our best bet is to try and find the primary data sets and work our way from there, and see whether those are permissive or not. And then set up the laser code so that we can start mining data. In parallel, I have to figure out the amount of compute that this will require, and then I got some forum for Stability AI where we can basically request some GPUs to do this open source replication. And Emad, the CEO of Stability, is fairly generous with this, as they have a ton of compute. Like the last time I checked, they have over 8,000 GPUs/TPUs. I think Emad mentioned that somewhere on Twitter. Okay, where is the data? Here is the data set. As I said, public bytex mined and data generated using back translation. Details are provided here. Here is the primary. So there is this script download parallel corpora of many publicly available sources of MT data which were used to train the NLLB models. You should provide a parent directory into which to save data. And there is some other data sets which they couldn't automate, so these three here. And then there is also the NLLB seed data, the mined data, and the back translated data. Okay, let's check one thing. Let's see this file here. And if I recall correctly, at the bottom here, they just call in the main function, they call a ton of these functions, and each of them downloads a particular data set. So how can we figure out the licenses behind? If we just take the MIT code and train on these data sets, can we then release a checkpoint using some permissive license? Probably all of these data sets have their own licenses. Machine translation for Turkic languages. So they don't even have the license file, which by definition means that it's not open source. And I'm not sure how all of this works. I'll have to consult with some of the folks from Eleuther AI. Maybe I can go and ping somebody from Eleuther AI server. Let me just think. Let me think for a second. I think I'm gonna offline after the stream basically just ping some of these people and consult with them. Do you guys have any idea on your side here? I think Lion is also always happy to sponsor projects like these. Yeah, that's a good point. I remember the early days of Open Assistant. Yeah, I know all those guys. I know I actually chatted with Yannick, who was one of the main developers there as well on the Open Assistant project. But the difference there is they collected all of that data themselves, whereas here, I think we can reuse some of these things. If we can retrain Laser, then we can just mine data as well. I know it's not gonna be easy, but that's the whole point. Over the next weeks, we're gonna start building this shit. Let's kind of check out these different data sets and see what's going on. So that was the first one. That was the till, right? And then there is the TICO. Let me just reopen to see. Okay, this was the Turkic interlingua. Yeah. Yep. Okay, this thing. Let's open up this link. Let me just quickly understand. Translation initiative for COVID-19. Huh. Other COVID-related collections from our contributors and our friends are listed here, which might not be available under permissive license. So what's the license? All content is publicly made. Creative Commons CC0. Okay, this is the most permissive license, right? So that means data sets like this one can be freely used. So TICO is good. Maybe we can. I'm using Notion here. I think I can just do something like this. Push this guy here, and then can you still see the screen? And I know it might be a bit smaller. So I'm gonna just start enumerating stuff that seems to be permissive. I'm gonna write down some comments here. So basically we have till TICO and then indic NLP. Given the growing size of monolingual parallel training data for indic language, we extend WAT 2020 indic languages task with additional languages and wave evaluation corpora. Why did these guys, like, what type of a website is this in 2023? I'm thinking maybe it makes sense. I think what makes sense is we don't really have to replicate NLLB for all 202 languages initially. We can just focus on like 1 or 2 language families just to scope down the problem even more. So like start from a small checkpoint, 600 million, and then focus maybe on Germanic or Slavic or something like that languages. Start from there. 11 million sentence pairs between English and Indian languages. So here is the data. It would be so easy if I was not doing this in open source manner and transparent manner. Imagine all of these companies are just like using whatever data they can gulp and they don't care. I think I'm gonna reach out to the Lion guys. Let me remember, he actually pinged me on Twitter. Well, I think I need to hide my personal messages for a second. I'm not gonna be that transparent on this stream. Let me just see what's the name of the Lion folks. Lion team Christoph Schumann. Okay, I actually have some chat with them. Okay, and it's as simple as that. So I'm trying to make Metis NLLB models, and this is fully open source, but I'm struggling a bit with licensing and understanding the space. Do you have some time for a call over the next few days or next week? Okay. I'm gonna ping Yannick as well. Actually, let's just start with Lion. Okay. Let's continue here. For general questions, comments, etc., email these guys. Why don't you just put the license? Like how can I know what I can use this for? Okay. This was the Indic NLP, right? Yeah. Lotus. Lingala song lyrics. Again, no license. This place is just this whole space is completely fucked up. It's just a legal nightmare. I think that's kind of the state of affairs. Web crap. I read web crap. No info in the repo. It's fun when you start actually digging into details behind these and you realize how messy all of this actually is. Nice, MIT license. Wait. What is this? Why does it say MIT license and then the next line, this work is made available under the terms of the license, Creative Commons attribution, no commercial use, sharing under. What the fuck? What is this? So yeah, that's why it's easier to just mine a ton of data than having to deal with everyone. Huh. So I don't understand. What does the MIT license refer to? Anyone? Why do they have MIT license here? And then CC. MIT may tell you about the CCBY and C. April Fool's joke. What the fuck is this? Okay. What's this? Mudirisano. Complete license. What do you mean? What do you mean by complete? What is complete in this context? . Okay, this is the version 3 CCBI 3.0. I think we're going to end up just mining data and training our system on the mine data. By the way, I'm just curious, and let's ask JGPT what else. What's the difference between version, my favorite legal consultant? What is the difference between let's see what's the difference. Yeah, but like it was confusing whether they mentioned MIT and then they mentioned this CCBY 4.0 license. Oh, wait. I didn't ask a correct question. Let's start a new chat. Let's just a second. Let's copy paste this. I forgot to add the NC part, right? This is how it looks like. Or no. What was this? This was just okay. There is apparently. Let's just ask what is this license? Okay, this is actually commercial. Welcome back, new guru. What's your name, by the way? You're a fairly frequent attendant of these weird late night streams. So basically this is Pablo. Nice to meet you. Yes, you can use content number. Okay. Yeah, I think as long as you don't have the NC, which means so NC stands for non-commercial. Yes. Thank you, ChatGPT. That's how you use this thing. So this is permissive as well. So maybe I can start like doing something like this. I don't know. I think it's also just interesting to go through these and understand the scope and the variance in these licenses, understand a bit the landscape. It's one of those things where Karpati took some time to go through ImageNet and understand how images look like. It's a very boring task, but like provides you some insights, I think. Okay, let's continue. What is this? Why does it have a PHP suffix? Why does the URL has a PHP suffix? License. No license. Please cite the following article if you use any part of the corpus in your own work. So I guess that means softly we can consider this as you just have to attribute, but you can use it freely. I don't know. I'm not a lawyer, but that's why I want to consult with these guys, client folks, etc. You can click on the various links. Vladimir just said yes. What are we referring to? I have no idea. I mean, if somebody didn't say something, does that mean you can use it? Or I think if we are being more conservative, then the assumption is if you didn't state it explicitly, then that person can always say they actually had they didn't allow you to use it commercially. I have no idea. Nothing explicitly said. It's kind of complex. I guess that's because most of these academic folks just don't care about commercial use cases, so they don't have to think about this. Let's continue. Menu 20K. Yoruba. This is some African languages. Okay. License for non-commercial use because some of the data sources like TED Talks require permission for commercial use. Yeah, that much I also figured out, but like I'm not sure about the footnotes. Download font French. What's this? For files, Creative Commons 4.0. So apparently machine translation space is tricky for a reason. Maybe I I started doing this. No, wait. This is just Creative Commons attribution. That should be permissive, right? Okay. Similarly, I think this is just the CC BY40 Creative Commons attribution. Okay. So this is permissive. It's just a version 4. Okay. My girlfriend will kill me. I'm streaming the whole day. Let me just see what this is. Wait, this was also some French, right? Okay, Zenodo, it's the same website. Can I assume we have the same license? Creative Commons Attribution 4.0 International. Okay, fair enough. This is also permissive. Oh, just a second. Okay. And then the next one is this one. They don't really, okay, I think they have, this is just a download link, so it's gonna start downloading a file directly. Yes. Let's see what's the checking out. Okay, Brian, see you tomorrow, man. We're gonna wrap it up soon in maybe 10-ish minutes. I'll see how much more we can go. Let me just check out this. It's getting close to midnight here in Belgrade as well. Creative Commons attribution to. Okay, so does that mean, okay, that probably means you cannot change it into non-commercial yourself if you derived from that work. So I would assume that this particular work is also permissive with version 2.0. So this is TCBI 2.0, which means it's permissive. That's how I'm reasoning about this. But like, we'll need some additional help, obviously. This is from the download like a poem function. Let's continue. There is this GELR. I think, was this one of the, yeah, this is the one they mentioned here. And they said that they cannot automate this for some reason. Let's see what's going on. License. This work is licensed under Creative Commons Attribution 4.0. Okay, awesome. So that means we can grab this work, GELR, and we can say it's CC BI 40. That means it's permissive. Okay, let's continue. JOSA media. How do you read this? Construcción de recursos para traducción automática Guarani-Español. I'm not sure what Guarani is, but this is some. Este repositorio contiene el trabajo desarrollado para el proyecto de grado. Let's see. Licencio, or how do you say that in Spanish? I forgot. Citations. So how do we figure out the license for this guy? What's Guarani? That's some weird language. Let's see. Guarani language is spoken where? Paraguay. South American language. Nice, interesting. Okay. Okay, contenidos. Do you really have to understand all these languages to understand what the license is? Okay, so they say if you use some of these resources, please cite. Okay, fuck. It says here non-commercial, and that was the. I'm not sure what grado means. Let me just. if it means anything. Maybe it's just a name. That doesn't make any sense. It's a big letter here, capital letter. Okay, it's not completely clear. Okay, let's continue. Let's see this one. GPL 3.0. That's also open source license, right? GPL. I'm gonna learn a ton about licenses, man. GPL. Anybody knows whether this is a permissive license? Let's see. GPL 3.0. My old friend. What am I working on? We are trying to figure out some details, some legal details behind some of the data sets, machine translation data sets that we need to construct the primary data set for the No Language Left Behind project for Meta, which we're trying to truly open source. That's kind of the TLDR. Okay, so this forces you, the GPL3 forces you to release with the same license that all of your derivative work. You must provide access to the source code even for modified versions. Okay, that's kind of imposing. So that's why it's stricter than MIT, because with MIT you can literally create it. You can now create some modifications and then use that as a proprietary piece of software. Okay, but like all in all, it is commercial. You can use it for commercial use cases. That's cool. That means this one is permissive. Let's see this guy. Now, Joe, did I answer your question? Let me know. Will these streams be a regular thing? Very much so. I'm planning to start doing these. Like I'll basically be doing the work I'm usually doing when I'm solo coding and doing stuff, but like this, I'm gonna be streaming. So I do expect to be streaming most days over the next period. I'll be going to Shanghai and Shenzhen over the next, like in a month. I got some invitation to go there, but until then, I think I'll be working my ass off on doing this. Critical Commons 0. Okay, this is the most permissive one. So basically this one is under CC0. That's permissive. Let me know if I answered your question. Why are you curious? Do you want to contribute or? Okay. This website is, we've frequently visited it for some reason. I'm not sure who these Zenodo guys are. Let me open this up. License, again, Creative Commons Distribution International. Okay, these guys are always CC BI4. So CC BI4 0. We can probably safely even assume that most of their stuff is going to be under the same license. Let's continue. We'll probably end up not using some of these just because we won't be covering all of the languages. Okay, this one is also CCBI for 0. Do you guys hear my typing on my keyboard? Just trying to understand the acoustics of these earbuds I'm using. If you're still listening, let me know. And also appreciate any feedback on these streams. We do, says Sarah. Nice. You do hear the keystrokes or what? Is it too loud? Data license. Let's check out. It's not. It's not open source. That's damn meta. Everybody thinks it's open source, but it's not. No, it's not. The code is, but the checkpoints are not. The data is not. That means you cannot use the artifacts to actually, for example, create a paid API and earn some money or whatnot if you want to do that. Okay, it is tolerable. Makes sense. And my sound is decent or? Okay, so basically this is also permissive. They just require attribution. So these guys, okay. That was a Haitian language. Okay, thanks. Let's see this one. What am I doing? We're trying to basically train new checkpoints. A little camera situation for tomorrow. Let me check up my camera. Yeah, it sucks. I'm gonna be using my Sony ZV tomorrow. It's just that my battery died, and so I'm using shitty webcam. Let's see this guy. I'm not sure what this means exactly. Is this permissive or not? Okay, let's just understand a bit better. This is for parallel news corpus in Turkish, Kurdish, and English. Okay, let's see. Simple question. No. Share alike is not a non-commercial. It's a license that allows others to use, remix, adapt, create, and share their derivative works under the same license. Okay, share alike. Okay, I'm slowly learning these terms. So share alike just means, so that's similar to GPL3. You have to share the derivative work under the same license, but you can still use it for commercial purposes. Okay. Obviously, I'm using JGPT with always with that grain of salt, but like when I see that reasoning makes sense, I'm confident that it's actually not bullshitting me. Okay, guys, I think we can actually well, that's the whole point, Vladimir. So basically, if we have the data that was not commercial, or we get like if we are allowed to use it commercially, then we can train checkpoints which are truly open source, and then you can you can host those open source models and earn money if you want. That's the whole point. Okay, this work is under. It turns out most of the work is actually permissive. That's cool. All of this is permissive. Or let's check out this one. License MIT. Wow, nice. That's super permissive. You can do everything you want with MIT license. All of my code was released under MIT license. All of my open source projects I've done previously. MIT rules. Okay, let's go. I think we have just a couple more, guys. We are done for the day. And then tomorrow, hopefully I'll have a reply from the Lion folks. I'll ping some Eleutherii friends as well, Yannick Kilcher. Okay, I don't see a licensing, oops, I don't see a comment here. Parallel corpora between 7 Ethiopian language themselves and with English. Whoever is using them for research and educational purposes should cite the papers. So there is no mention of commercial use cases, which means this is not, doesn't look to be permissive. They only mention research and education, hence likely non-commercial. So that was that one. And are we done? Are we done? I think we are. Guys, I think this was the last one. Am I correct to assume that? Yes, Ethiopian languages. This was the website we've just been to before. Yeah, that's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 datasets there. Can I somehow count this automatically, or I have to count in Notion again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. What? Oh my god. Okay. It looks like I probably double counted some of these, but I think we covered all of these. So this is the first part. Next up, we have to figure out the licenses. So this is for the primary data set. Let's figure out the mined data set. Questions is laser is can we use laser 3 to mine data, and it'll be open source. And then that's one question. Although Open Assistant is basically part of Lion, so that's the same thing. Okay, so that's gonna be next steps tomorrow. We're gonna figure out the mined dataset. Laser 3, is it can we just use that checkpoint and use it to mine our own data, or is the laser 3 also non-commercial itself? And once we figure out the data, then the next steps will be to start the data collection, think about compute, maybe reach out to Stability AI for a potential grant in compute. We'll need a ton of GPUs, guys, to actually train the NLLB. Well, for smaller checkpoints, we are fine. Even with maybe 16 to 32 GPUs, we can train those smaller ones fairly quickly. But even on a single node with 8 GPUs, I think we will be able to do it. But like for bigger checkpoints, it's going to be more difficult. So that's the plan. We first attack the data part. We get data that we are confident about, and then we can maybe do some. I think we should spend some time analyzing the data, cleaning, understanding the data, maybe focus on spend some time and then after that we can basically binarize shard all of that data and start training the models, because the code base for fairseq for NLLB branch is MIT licensed, so we can just do everything there. And then yeah, so we can maybe even, depending on the involvement from folks, we can maybe even release a paper, some quick short paper or something, sharing the findings from this effort. And that would be day one. So in day one, let me just quickly write it down here what we've done. We have first two streams, we're covering the SeamlessM4T paper. The third stream went through the seamless. Okay, Vladimir, see you later. Have a nice night. Went through the seamless, and see you tomorrow. For T code base plus fairseq2 plus we went through the dataset licenses. Guys, Johnny, have a nice night in case you're somewhere in a similar time zone as I am. Navjot, which particular sources will you use to mine data from? Well, that's all TBD. I don't have answers on top of my head. Papers contain information, so that's not gonna be the hard part. Let me just kind of log down some of these details. Licenses, and made a plan for tomorrow. So tomorrow, as I said, well, we can figure stuff on the fly as well tomorrow. So that was day one, and then tomorrow we'll have day two. Okay, guys. Hopefully this was interesting. Let's see how it goes. It was first one for me. I've never streamed before. I'm honestly enjoying this. Like just talking out loud and chatting with you is helping me clarify my thoughts, to be honest. And I feel also more motivated, even more than when I'm doing this solo. There is something super nice about streaming this work. So yeah, guys, have a nice night in case you're in such a time zone. Otherwise, have a nice day, and catch you tomorrow. So I'll be streaming. Let me write down some times. So 10 a.m. let's say 10:30 a.m. CET is when we're going to start, and then probably all the way to like, I don't know, maybe even, we'll see how it goes. Maybe I'll have two chunks, like maybe 10:30 to like maybe 3 p.m. and then maybe one more like this, and then I'll do some workout, and then after the workout again we can stream from 9:30 to like 11:30 p.m. We'll see. This is just like preliminary stuff. Okay guys, see you tomorrow hopefully and over the next days. And if you want to contribute, check out the channel here on Discord. I created a separate channel here in the Meta NLLB replication, this channel, and I'll be just sharing more information there. Just join the server if you haven't already. The Epiphany, my name, Aleksa here, and that's it. Closing down the stream. Cheers.